Hey everyone, welcome back to the channel. Today, we're diving into a topic that every React developer should be prepared for: the most tricky questions for react.js. Whether you're preparing for an interview or just want to test your knowledge, these questions will challenge your understanding of React's core concepts and edge cases. Let's get started and see if you can crack these tricky questions. Why tricky questions matter. Before we jump into the questions, let's talk about why tricky questions are important. They're designed to test your depth of understanding, attention to detail, and ability to handle edge cases. These questions often reveal whether you truly understand how React works under the hood or if you've just memorized the basics. Ready to test yourself? Let's go! Alright, let's dive into the questions. I've categorized them into different areas of React to cover all the bases. Let's start with state and props, the backbone of React. What happens if you call setState multiple times in a row? Does React batch these updates, and how does it affect rendering? This tests your understanding of React's batching mechanism and how state updates work under the hood. Answer: without functional updates, handle click. React schedules state updates but doesn't immediately reflect them. Since count remains the same during execution, all three setCount, count plus 1, calls use the same stale value, causing only a single increment. With functional updates, handle click with functional update. React processes updates based on the previous state. Each update receives the most recent state, ensuring the count increases correctly. Can you modify props directly in a child component? What happens if you try? This checks your knowledge of React's immutability principle and why props are read-only. Answer: understanding props flow. In our parent component, we define a state variable message using useState, hello from parent. We then pass this message as a prop to child component. This follows React's one-way data flow, parent-child. Trying to modify props in the child. Inside child component, we receive message as a prop. Here, we try to reassign message inside the child. React does not allow direct modification of props. This can lead to unexpected behavior and React strict mode will throw an error. What happens when we run this code? If React strict mode is enabled, you'll see an error in the console saying, type error, cannot assign to read-only property message. How to handle this correctly? Instead of modifying props, we should use callbacks from the parent or maintain a local state. Here, we pass update message as a prop, so the child can trigger a state change inside the parent instead of modifying props directly. And that's it, folks. Rocket props in React are read-only, and the right way to change data is by lifting state up using callbacks. Next, let's look at some tricky questions related to component lifecycle methods. What's the difference between component didMount and useEffect with an empty dependency array? Can they be used interchangeably? This evaluates your understanding of class components versus functional components with hooks. Key difference. Component didMount, class component, runs once when the component mounts. UseEffect, function component, also runs once, but it's used in functional components. Can they be used interchangeably? In most cases, yes, but function components don't have lifecycle methods, so useEffect is the modern replacement. While both run after the component mounts, they have key differences. Timing. Component didMount runs immediately after the first render, while useEffect runs after the browser has painted. Cleanup. UseEffect provides a cleanup function, similar to component willOnMount, while component didMount doesn't. React strict mode. In development with strict mode, useEffect can run twice, but component didMount only runs once. Context. Component didMount is only available in class components, while useEffect is for functional components. Let's discuss with demo app. Each component loads data after mounting. The timestamp shows when each lifecycle method fires. You can force re-renders to see how they behave. You can unmount/remount the components to see unmounting behavior. Check your browser console for additional logs. Use component didMount when you're working with class components. You need to interact with the DOM immediately after render. You're integrating with non-React libraries. Use useEffect when you're working with functional components. You need cleanup functionality. You want to better separate concerns in your component. Common gotchas. In development mode with strict mode, useEffect runs twice to help catch bugs. The cleanup function in useEffect runs both when unmounting and before re-executing the effect. Neither should be used for data that updates frequently. Use state or props as dependencies instead. Next, let's look at another question related to component lifecycle. If you call setState inside component will unmount, what happens? Is it a good practice? This tests your knowledge of lifecycle methods and their limitations. Here's a React class component that tries to update state when it's unmounting. Let's see what happens. Boom! React warns us that we're updating state on an unmounted component. Not good. Why it's bad? The state update is ignored. React won't actually apply the state change. It causes warnings. React explicitly warns against this practice. Performance is wasted. React still has to process the state update request, even though it won't do anything with it. It violates the component lifecycle. Component will unmount is meant for cleanup, not for making new changes. Potential memory leaks. In complex applications, this pattern can contribute to memory leaks. It can mask other issues. Getting in this habit might hide actual bugs in your application. Code breakdown. We have a component that updates a counter every second. When unmounted, it tries to reset the counter and change a mounted flag. These state updates are completely ignored. React will show a warning in your console in development mode. Fix. Cleaning up timers, like we did with clear interval. Canceling network requests. Removing event listeners. Any other cleanup that prevents memory leaks. Bonus tip for modern React. If you're using modern React with hooks, the equivalent would be the cleanup function in a useEffect hook. Now, let's move on to hooks, a powerful feature introduced in React 18. What happens if you call a hook inside a conditional statement or loop? Why is it not allowed? This checks your understanding of the rules of hooks and how React relies on the order of hooks. If you try to call React hooks, like useState or useEffect, inside conditional statements, if, switch, ternary operators, loops, for, while, for each, nested functions, React will throw an error in development, and your app will behave unpredictably in production. What happens when you break this rule? In the code example I've created, we have a bad component that tries to use hooks conditionally and in loops. A good component that follows the rules of hooks. When you break this rule, several bad things happen. React relies on hooks being called in the exact same order every render. The first hook value might end up in the second hook variable. Cleanup functions might never execute. These issues are extremely difficult to track down. Why does this happen? The hook order matters. React uses the call order of hooks to determine which state belongs to which hook call. There's no other identifying information. Imagine React keeping an internal list like this. If a conditional changes which hooks run on the next render, the entire order gets messed up, and React will associate the wrong state with each hook call. The right way to use hooks with conditionals. Instead of putting hooks inside conditionals, you should call all hooks at the top level of your component. Use conditional logic inside the hooks, like in the effect function. Conditionally render JSX based on state, not conditional hooks. Practical tips for common scenarios. Always declare the hook, conditionally use its value. Put the condition inside the effect function. Use a single array/object state instead of multiple hook calls. The ESLint plugin for React will catch these errors during development, saving you from these hard-to-debug issues. How does useMemo differ from useCallback? Can you give an example where using one is better than the other? This tests your ability to optimize performance using hooks. Ever wondered what the difference is between useMemo and useCallback? They both optimize performance, but they do it differently. Let's break it down with simple examples. Use memo versus use callback. When to use each React hook. Key differences. Memoizes values. Memoizes functions. Returns a cached value. Returns a cached function reference. Best for expensive calculations. Best for preventing unnecessary re-rendering. Runs the function and stores the result. Stores the function itself. When to use memo. Let's say we have an expensive calculation that only needs to run when a specific value changes. Got a slow calculation? Wrap it in use memo so it only runs when necessary. Why use memo here? Prevents unnecessary recalculations when number hasn't changed. Improves performance by only running the computation when needed. When to use callback. If we pass a function as a prop, React recreates it on every render, causing unnecessary re-renders of child components. Use callback prevents this. Passing functions to child components? Wrap them in use callback to prevent unnecessary re-renders. Why use callback here? Ensures increment doesn't change on every render, so button doesn't re-render unnecessarily. Useful when passing functions to memoize child components. Final takeaway. If you're optimizing values, use memo. If you're optimizing functions, use callback. Let's move on to rendering and reconciliation, one of the most complex parts of React. Why does React use a virtual DOM, and how does it decide when to re-render a component? This evaluates your understanding of React's rendering process and performance optimizations. What is the virtual DOM? Think of it as a lightweight copy of the real DOM that React uses to optimize updates. Instead of modifying the real DOM directly, which is slow, creates a virtual DOM representation of your UI. Compares, diffs, it with the previous version. Only updates the changed parts in the real DOM, efficiently. Without virtual DOM, inefficient. Imagine updating a single text inside a large web page. Traditional DOM updates refresh the entire page. Let's see how React decides when to re-render using a simple counter. What happens here? Each time setCount is called, React creates a new virtual DOM and compares it with the old one. React only updates the part that changed, the number in H2, not the entire UI. When does React decide to re-render? React triggers a re-render when state changes, useState, useReducer. Props change, parent component sends new data. Context changes, if using useContext. But React does not re-render when the same state value is set again, setCount 0, when count is already 0. The parent re-renders but the props didn't change. Optimizing re-renders, with react.memo and use callback. If a component re-renders too often, use react.memo. The virtual DOM makes React fast and efficient. What's the difference between keys and refs? How do keys help React during reconciliation? This tests your knowledge of React's diffing algorithm and how keys prevent unnecessary re-renders. Ever wondered what the difference between keys and refs is in React? And why does React scream at you when you forget to add keys in lists? Well, today, we are diving into that. What are keys and refs in React? How keys help React during reconciliation? A practical example to clear up any confusion. What are keys in React? Keys are special string attributes that help React identify which items in a list have changed, been added, or removed. Key properties are: must be unique among siblings. Typically use IDs from your data. Should be stable across re-renders. Not accessible in components. What are refs in React? Refs provide a way to access DOM nodes or React elements created in the render method. Ref properties are: access DOM nodes directly. Persist between renders. Can be attached to DOM elements or class components. Accessible via .current property. How keys help during reconciliation? Without keys, React has to modify every item in the list during updates. With keys, React can identify which elements have changed. Benefits of keys. Create only necessary DOM nodes. Preserve state for components that persist. Avoid unnecessary re-renders. Keys versus refs, the comparison. Purpose. Keys help React identify elements during reconciliation. Refs access DOM nodes or React elements directly. Usage. Keys is required for list items. Refs is optional for direct DOM manipulation. Accessibility. Keys is not accessible in components. Refs is accessible via .current property. When to use. Keys use when rendering arrays of elements. Refs use when you need to access DOM elements directly. Summary. Keys are for React's internal use during reconciliation, while refs are for your code to access DOM elements directly. Finally, let's look at some advanced concepts that often trip up even experienced developers. What is the difference between controlled and uncontrolled components? When would you use each? This checks your understanding of form handling in React. Controlled components. Controlled components are React components where form data is handled by the component's state. React is the single source of truth for the input value. Key characteristics. Form data is controlled by React state. Changes trigger state updates via onChange. Value is always driven by React state. More control over form validation and submission. Try it out. Uncontrolled components. Uncontrolled components are where form data is handled by the DOM itself. Values are retrieved using refs instead of being controlled by React state. Key characteristics. Form data is handled by the DOM. Uses refs to access current values. Can use default value for initial values. Less code for simple forms. Try it out. Controlled versus uncontrolled comparison. Form data storage. Use React state. Use DOM. Access method. From state variables. Via refs. Input changes. Trigger state updates. Handled by DOM. Real-time validation. Easy to implement. More complex. Initial value. Value equal to null. Default value equal to null. Boilerplate code. More. Less. Debugging. Easier, state is tracked. Harder, DOM mutations. Controlled components. Pros. More control over form values. Easier to implement validation. Consistent with React's data flow. Changes are reflected immediately. Cons. More boilerplate code. Need to handle every input change. Can be verbose for large forms. Uncontrolled components. Pros. Less code for simple forms. Good for one-time form submissions. Simpler implementation. Works well with non-React libraries. Cons. Less control over form behavior. Harder to implement validation. Values only available on submit. Not as predictable. When to use each approach. Use controlled components when you need instant field validation. You want to conditionally disable the submit but tone. You need to enforce input formats, e.g., credit card. You need to dynamically change form fields. You're building a wizard-style form with multiple steps. Example, login forms, registration forms, search forms, and any form requiring real-time validation. Use uncontrolled components when you need to integrate with non-React code. You're building simple forms with minimal validation. You want to leverage native HTML form validation. You're converting a legacy application to React. You need to handle file inputs. Example, file uploads, simple contact forms, and forms where you only care about the final values. How does React handle errors in components, and what are error boundaries? Can functional components have error boundaries? This tests your knowledge of error handling and the limitations of error boundaries. How React handles errors. By default, when an error occurs in a React component, it causes the entire component tree to unmount. This creates a poor user experience as the entire UI disappears. Error types in React. Render errors occur during the rendering phase. Event handler errors happen during event callbacks. Lifecycle/hook errors in lifecycle methods or hooks. Async errors in promises or async code. Without error handling, will crash your app. Development mode. In development, React replaces the crashed component with an error message screen, highlighting the error and component stack. Production mode. In production, React unmounts the entire component tree, showing a blank page or whatever fallback the parent provides. Error boundaries. Error boundaries are special React components that catch JavaScript errors in their child component tree, log those errors, and display a fallback UI instead of crashing. Key features. Act like JavaScript catch blocks, but for components. Only catch errors in the components below them. Can't catch errors in event handlers, use try/catch there. Introduced in React 16. Must be implemented as class components. How to use error boundaries. You can wrap individual components, routes, or your entire app with error boundaries. It's a good practice to have multiple error boundaries at different levels. Error boundary lifecycle methods. Static get derived state from error used to render a fallback UI. Component did catch error info used for side effects like logging. Error boundary demo. Below is a live example of an error boundary in action. Click the button to increment the counter. When it reaches 5, the component will throw an error. Error handling flow. User clicks the increment button multiple times. When counter reaches 5, component throws an error. Error boundaries get derived state from error catches it. Component did catch logs the error to console in this demo. Fallback UI is displayed instead of the crashed component. User can reset the error state with the try again button. Functional components and error boundaries. Can functional components be error boundaries? No, functional components cannot be error boundaries. Currently, only class components can be error boundaries because there are no hook equivalents for the error catching lifecycle methods. This does not work as an error boundary. Recommended pattern for functional components. The best practice is to create a reusable error boundary class component and then use it within your functional components. React Teams explanation. Error boundaries are React components that catch JavaScript errors anywhere in their child component tree. Currently, only class components can be error boundaries. And that's a wrap. These tricky questions will not only help you prepare for interviews but also deepen your understanding of react.js. If you found this video helpful, don't forget to give it a thumbs up, share it with your friends, and subscribe to the channel for more React tips and tricks. Let me know in the comments which question stumped you the most or if you'd like me to cover more topics like this. Thanks for watching, and I'll see you in the next video. Happy coding! Subscribe for more React tips and tutorials.